Hey Andrew, I realized my other video had no sound. I'm not sure why. So I'm going to go through this quick and I'll walk you through it a little bit. Where did I put you? Tutoring. 43. Okay, here we go. Alright, so at the top here, I just wrote a couple relations, really no equations here. Just different conversion rates. So I've got 2 pi radians is equal to 1 revolution. So the units here are radians and revolutions. Converting from 2 pi r is also equal to 1 revolution, where the r term is some linear term like meters or inches or feet or something like that. So I wrote meters, for instance, to convert to revolutions. And then we've got 2 pi radians equals 2 pi r. So that's from radians to some linear distance, meters, inches, whatever. And then at the bottom, I've just related them all to each other. 2 pi r equals 2 pi radians equals 360 degrees equals 1 revolution. So in the first example, we've got CD spins 2.5 radians. So it's some concrete distance, some finite distance. How many revolutions has it spun? So we write down, this is the way I do conversions. I'm not sure how you learned it all. I find this is the neatest way to present it. It's easier to understand. So I write 2.5 radians. And then I want to choose the conversion that has radians and revolutions because I'm starting with radians and I want to get to revolutions. So I'll go up top here and I'll look at my different conversions. So I would pick 2 pi radians is equal to 1 revolution. So then the question is, do I put revolutions on top or do I put revolutions on bottom? In this case, I want to put the 1 revolution on top and 2 pi radians on the bottom because I can get the radians to cancel. Radians is a unitless unit technically, but when you're using conversions, you still want to factor it. You still want to account for it. If I had put revolutions on bottom, then I would have 2 pi radians divided by 1 revolution, and then I've got radians squared over revolutions. That's not the right unit I want. So I'll write radians on the bottom, and then my radians cancel. And I'll just multiply all the numbers on top, divided by, and then multiply all the numbers on the bottom. And the only units I'm left with are revolutions. So if I do the math, I get 0.398 revolutions. Next example. We've got a ball spins at 5 revolutions per second. How fast does it travel in radians per second? So a couple things to note when looking at the units here. I'm going from revolutions per second to radians per second. I'm not trying to change the time unit at all. I'm just trying to change revolutions to radians. So I'll do exactly what we did in the last problem. I'll write down 5 revs over seconds, and then I'm going to go back to my conversions. And it's going to be the same conversion that we used in the last problem. The only difference is I'm starting with revolutions. Now I want to get to radians rather than starting with radians and going to revolutions. So I'll use the same conversion, but now I'll write revolutions on the bottom, radians on top, so I can get the revolutions to cancel with the revolutions. And what am I left with? 5 times 2 pi all over just 1, and my units are radians per second. You do the math and you get 31.42 radians per second. Then we'll go over here. Our third example, I know you would ask for radians and revolutions, but I threw in another one with degrees. So I've got a ball spins in a circle at 120 degrees per second. Convert that velocity to revolutions per minute. So we've got 2 things here. We need to convert from degrees to revolutions and seconds to minutes. So I'll write it in. I'll write 120 degrees per second. Then I need to find something. You need to find a different conversion for each one. By each one I mean the degrees to revolutions and the seconds to minutes. So we'll go back up top to our other paper. And we have that 360 degrees is equal to, what did I have, revolutions I want to go to? Revolutions. 360 degrees is 1 revolution. So then I'll come down here. I'll write 1 revolution divided by 360 degrees so that my degrees cancels. So now I'm in revolutions. But now I want to get seconds into minutes. So I'll use 60 seconds over 1 minute. Why do I write seconds on top, minutes on bottom? So that the seconds cancel. And now what am I left with? In units wise, I'm left with revolutions over minutes. to get my magnitude, I'll multiply 120 times 1 times 60 divided by 360 times 1 revolutions per minute, and that comes down to 20 revolutions per minute.